Hey all, today we are going to continue talking about probability, and we're going to be talking more about, mostly about some probability rules, some general probability rules that we used to an extent when we talked about probability models, but we'll add some on as well. So a couple basic rules of probability. The first one is that when we have a probability, um, it's always going to be some value between 0 and 1. So when we calculate probabilities, the decimal is what we call the probability. And then if we move that decimal place 2 places to the right and get a percentage, that's like a percent chance. So probability should always be somewhere between 0 and 1. You can include 0 and you can include 1. That means that if we have a probability of 1, that's a guaranteed. That's going to happen. And then if we have a probability of 0, that means it won't happen. Anything in between um, could happen. The closer you get to 1, the more likely something is to happen. The closer you get to 0, the less likely it is to happen. If we have something like a probability model, like we talked about the geometric probability, the binomial probability distributions or models, and we just talked about random variables to start this unit. All the probabilities of all the possible events or all the possible outcomes must add up to 1. So, for example, when we all the way back to the probability or the random variables lesson, we had this restaurant where you flipped a card and you could either get a discount, or you could flip another card and get a partial discount, or if you flipped a black card then you didn't get any discount. The probabilities of all those possible outcomes added up to 1. So we always, whenever we have multiple outcomes, the probability of those outcomes will add to 1. This is another thing we sort of dealt with. This is called a complement. So if we have a probability of event A happening, this here is what we call the event. So the probability of any event happening is equal to 1 minus the probability of its complement. So for example, on a multiple choice test, there typically, okay, for us there are 5 options: A, B, C, D, and E, and there is one right answer. So the probability of guessing correctly on a 5-choice multiple choice question is 20%. And so the probability of being wrong is 1 minus 0.2. 0.2 would be its complement, being right. And we would say, so the probability of guessing wrong is 0.8, so an 80% chance of guessing wrong. So take a second here and read through this about driving through traffic lights. So we have some data collected, and 35% of the time the light is green when we go through this intersection. And so we want to find the probability that it isn't green. And so that would be the complement of being green. So the probability of, I'm going to say, not G is equal to 1 minus the probability of being green, which is 1 minus 0.35, which is 0.65. So the probability of the light not being green is 0.65. The percent chance that you drive through and it's not green is 65%. The next idea is the addition rule, which we will talk in more detail about in a future lesson. But for now, this is sort of the general addition rule, that if we want to know the probability of one event or another event happening, we would add. So this symbol means or. So this is the probability of A or B happening. If they are disjoint or mutually exclusive, that means if we could draw a Venn diagram and the two circles don't overlap, event A and event B, that makes them mutually exclusive. That means they can't both happen at the same time. They're disjoint or mutually exclusive. Both words work. That means these two events cannot happen at the same time. So if you were to look at a diagram of those Venn diagram of those events, the two circles wouldn't be overlapping at all. And so here, give me 1 second. So here I'm trying to find out the probability that my light is red, knowing that what the probability of green is and now what the probability of yellow is. So I can find out the probability of it not being red. When it's not red, it is green or yellow. I'm just going to use capital letters. That's not the probability of Guy, it's the probability of green or yellow. We would add the two probabilities together because they are mutually exclusive events. A traffic light cannot be green and yellow at the same time. It has to be one or the other. So we can just add those probabilities together. And now we can apply our complement rule to find out the probability the light is red. I'll use R and subtract 1 minus being green or yellow. Probability of the light being red is 0.61. So we use our addition rule here to find the probability that it's not red. And then we use the complement rule to find the probability that it is red, because being red is the complement of being green or yellow. We were only allowed to use that rule again because the two events being green and yellow are mutually exclusive. They cannot both happen at the same time. And our last basic rule would be the addition rule, or the multiplication rule, sorry. This symbol means and. This is when we want two things both to happen. This is the probability of event A and event B happening. And much like with the addition rule, we have a stipulation on this. Our events need to be independent. That means if event A happens, we need it to not change the probability that event B happens. If it does, then we're dealing with something else, and we will definitely discuss that in a future lesson. So my light being green, for example, on one time I drive through the intersection cannot affect the probability that the light is yellow or red the next time through. And that seems like it's reasonable. So here we want to know the probability that we have a red light on Monday and Tuesday. So we want to know what is the probability we are red and red 2 days in a row. And so we can take the probability of a red light on the first day and multiply it by the probability of a red light on the second day. These are independent events because hitting a red light on Monday is not going to change the probability I hit the red light on Tuesday. And so I can get that probability to be 0.3721. And I like to do 4 decimal places if these decimals are long. This way I can convert to a percentage and still have a couple decimals after, or a couple numbers after the decimal. So this one sort of tacks on to this. We want to know the probability we don't encounter a red light until Wednesday. And so that is the probability that we get the complement of red, which is green or yellow. And again, the complement of red on Tuesday, and then we hit a red light on Wednesday. So these are all independent events. Hitting a red light or not hitting a red light is not going to change what happens the next day. It's not going to change the probability. And so if we go back up, the probability of green or yellow we found already is 0.39. And so that would be our first 2 days. And then the probability of red on the third day is the same as it always would be, 0.61. And so we can multiply these three together. So we would say this is around a 9% chance, 0.0928 probability, pretty low probability, but that doesn't mean it's impossible. It's just not highly likely. We want to find the probability now that we need to stop at least once during the week. At least once means we'll hit a red light 1 day, 2 days, 3 days, 4 days, or 5 days. Those are all possibilities. So the opposite of that would be the probability of not stopping, so no reds. So that would be either a green or a yellow each day of the week. And so we can find that probability of not hitting any reds by multiplying 0.39 5 times. This is an and probability. What's the probability that we don't hit a red Monday and Tuesday and Wednesday and Thursday and Friday? They're all independent of each other because being able to drive through the intersection one day is not going to affect the probability I can do that the next day. You might see this as 0.39 to the 5th power, and that's good. And then I could find the probability of stopping at least one time, because that is the complement of not stopping at all. So I can do 1 minus 0.0090 and get 0.991. So it is highly likely that we will have to stop at least once. That means once, twice, 3 times, 4 times, or every day. So just some examples of using these rules. Now I have some questions I want you to work on. You can always ask for help. You can work together. So I want you to answer these 3 questions down at the bottom about M&Ms. Use the examples we did in the lesson to help you. Use me to help you if you need help. You can work together, but put your answers to these questions when the boxes pop up. Same thing here. Answer all of these questions. Again, you can use our examples for help. You can ask me for help. You can ask a friend for help. The point is to practice this stuff and start getting a good understanding of how to apply these rules of probability. Take your time on these, and good luck.